And this is Mr. Ashton going through the final one, PPE4, which was the numeracy calculator exam for higher tier. So page 2 obviously got our formula sheet. You will need to use this one here on one of the questions. I think that's pretty much it. And this actually comes into use later on, and I'll come back to that later. Okay, so question 1 says a ribbon is tied around all the faces of a box as shown in the picture. The ribbon is placed across each face of the box and meets all the edges of the box at right angles. A bow is tied on top of the box using 18 centimeters of ribbon. The box has length L, so this would be what I call the length here. Width W, so I'll call that bit the width, and height H. And it says write down an expression needed to decorate the box. So in terms of what I've got, I'm going to have on the bottom, I'm going to have the length there, and I've got the length on the top. So I'm going to have two L's plus the width. Now, as you can see, it's gone across there, and it will be underneath, won't it, I assume? But it doesn't come across here or here, so it's two of the widths. And then the height will be this one here, that one there, and that one there. So that would be plus 4 of the heights. And then finally, don't forget the bow, and they told us we needed 18 centimeters of ribbon for that. So it was 2 of the lengths, 2 of the widths, 4 of the heights, and 18 altogether to do the bow. Number 2. Okay, so this is our OCW. You can see that quite clearly, so I've got to make sure that I'm writing and explaining. I don't want to leave any calculations without sort of explaining what I've done. So, first of all, I'm going to rewrite out this exchange rate that I've seen straight away, which is £1 is equal to 4.3. I'm just going to call it Z for zloty. And then to change the pounds into zloty, I want to times by whatever this number is. Just put a line through there so it looks like a nice 7. And then to change the zloty back into pounds, I would divide by 4.37. Okay, so it says Lech went on a holiday from his home in Wales to Poland. Before going, he went to his local money exchange to buy some Polish zloty. He only had 250 quid to spend on zloty. He wanted to buy as many zloty as possible. Unfortunately, the money exchange shop only had 50 zloty notes. Now that just means every note was a 50. They didn't have like any 10s or 20s, they're all 50s, okay? So the exchange rate was 1.437. Okay, how much did he pay for zloty? Well, he had 250 quid. So I'm on the pounds there, and I want to change to zloty, so that means I'm timesing by 4.37. So that is going into my calculator. 250 times by 4.37. That comes to, if I can find that answer again, sorry, comes to 1092.5 zloty. Okay, that is a 5. Now, in terms of what this means, I know you can only buy 50s. You can only get his money in 50 zloty notes. So that means he can buy 1,050, because obviously he could get to 1,000 no problem, and obviously he could get to 1,050 no problem. But 1,100 or 1,100 he can't. He can't afford it, and he only has 250 quid, so he can't. How much does it cost him? This costs. So this would be the 1,050 zloty that he has, divided by 4.37. So divided by, turn it back into pounds, comes to £240 and 27 pence. And because it's an OCW, I'm going to make sure I've said that I've rounded my answer to 2 decimal places. And I need to just reference why this is. He can buy that as exchange shop only has 50 zloty notes. Okay, I think I've done a good job there of explaining everything. Might just say here how to change pounds to zloty. Okay, so while in Poland, he spends 340.40 zloty. On returning to Wales from his holiday, he wants to change the zloty back. Unfortunately, the exchange shop would only buy back a whole number of zloty. Okay, so they can only buy like whole ones, not like pennies or coins or anything like that. The exchange rate used to change zloty back to pounds was £1 equals 4.43. So I'm going to write that again. And that's going to be times by 4.43 to change pounds in zloty, divide by 4.43 to turn it back. Now this bit isn't OTW, so I don't need to go and explain what I'm doing there. Unfortunately, so we got to that bit. Calculate how much he received back. Well, we know he took away 1,050, didn't he? He's now spent 340.40. He's taken out way too many there. In real life, just be careful with that because you do actually get stung a bit by changing it back. 340.40 comes to 709.60 zloty, but they'll only buy back, whole zloty. Whole number of zloty. So you do 709 divided by 4.43. You've got to keep the 60, the 0.60, it'll be like coins. So I always keep them as like a little souvenir. If you go in my classroom, you'll see that I've got a load of those up in my room. And then changing that back comes to £160 and 5 pence. And again, rounded to 2 decimal places. Okay. Number 3. Sabrina sees the following advert. Borrow money today, why wait until payday? It costs 1% per day compound interest. 2 weeks time, they've just told us in days. They're trying to get us to go wrong there. Just watch out for that. They've always got to be in the same unit. So 2 weeks is 14 days. She decides to borrow 400 quid for a period of 2 weeks. How much will it change? Now, we've used this formula. The formula we tend to use is money times by. Now, the way that I do it is as follows, but your teacher might do something different with you, or you might do something different. Plus or minus the percentage in the question, percentage given, and then to take it out of percentage, I divide that by 100, or you can just go straight to a decimal if you know what that is, and that is to your time there. Now, I know the time is 14 days, I know the money is 400 quid, and I know because I'm going to have to pay interest on it, I need to add. If I was losing money, like say in like a car going down in value, I'd take away this number. So it's going to be 400 times by 1 and then plus 1%, so 1 divided by 100 to the power of 14. Now some of you in the actual exam wrote it in repeatedly and I was a bit, thinking you're wasting a bit of your time here in the exam. Be careful, this form is very, very, very easy to use, and if you don't know it now, I recommend that you do know it because it is very, very, very quick to use. Okay, so there's my answer, and again, round that to 2 decimal places, so 7.9 to 2 decimal places. Okay, question 4. Now, quite a few marks going for this, so be careful you don't make a mistake on the next bit, the part B in particular. So it tells us the North Hoyle offshore wind farm is approximately 7.5 from the coast of North Wales. Well, that's great. That doesn't mean anything to me. They'll tend to put in information that is irrelevant to us in a numeracy style question. When this wind farm opened, it was working at 35% of its capacity. It had enough. What to say? And it produced enough annual electricity for 50,000 homes. So I know that 35% was equal to 50,000 homes. Now what I'm going to do is find out, I want to find out 100%. It says what is it like at full capacity, so I want to find out 100%. Now that's not a miscue here. I'm going to find 1% because if I can find 1%, it'll be very, very easy to find 100%. So I'm going to do that by dividing both sides by 35. So 50,000 divided by 35 comes to a horrible number. Don't round that, you never round until your very final answer. 5. Now I don't like that dot above the 5, so I'm just going to press SD and get rid of it. And then I'm just say dot dot dot. And then to change that to full capacity to 100%, times that by 100. And then I will round this to the nearest whole number. So that'd be 142,857 whole number. Say that I've rounded. Okay, or homes. Okay. Okay, now part B was the bit where lots of us lost marks on here. There was one answer. If you've got 1.36 and you've got no marks, that's not a mistype. That's genuinely no marks. It's very, very, very close to the answer I'm going to get though, but you used the wrong maths to do it. Okay, now it's said that there are many offshore wind farms across the coast of Wales, Scotland and England. The full power of the individual wind turbines is different in various wind turbines. The table shows the information for 4 wind farms. So it's got these 4 different places here, full power of each turbine and the number of turbines. Now, what it made sense to me to do is to do a combined amount to work out exactly how much each one of those wind farms was chucking out. So to work this one out, I just want to do 2 times 30, which is 60. And then I want to do 3.5 times by 54, which is 189. And then 3.6 times 25, which is 90. And finally 3 times 60, which is 180. I can work that out. So I can work out that there is a total here. So my total, if I add all of those numbers together, so 60, add 189, add 90, add the 180, comes to 509 megawatts altogether. That's exactly how much all of these things chuck out. And the total number of wind turbines I'm going to add together, so 30, add 54, add 25, add 60, comes to 169 turbines. Now it says if each of these wind farms worked at 45% of full power, what would the mean power be of the single wind turbine? Give your answer to 2 decimal places. So what I'm going to do is work out what it would be at running at full value, which would be 519 megawatts divided by the 169 turbines. So 519 divided by 169 comes to 3. Now I don't like that point again, so I just press SD to make it more manageable. 3.071 blah blah blah, but I don't round that because I'm not finished. Now it said 45%, so I could do the same sort of trick that I just did. I could say 100% is equal to the 3.07 blah blah blah, 1% by dividing by 100, and then 45% is equal by blah blah blah, and work it out that way. Or a quicker way, so it's not wrong to do it that way, but quicker is to say 45% is 45 out of 100, or if you know that, it's 0.45, and then multiply it by that 3.071 blah blah blah. So that answer times by 0.45 or times by 45 or 100 is the same thing, comes to an answer of 1.38 megawatts to 2 decimal places as requested in the question. It said 2dp. Okay, so this page was just working for that, but I've done it all on one page. So over the page, okay, now just be careful. This is question 5. This is probably not going to be a histogram if it's this early on. And you can see here it says frequency, so it's not frequency density. We like this graph, it's a lot easier than doing a histogram. So here it says the frequency diagram shows the times taken by local people to tie a Celtic knot for the first time. So reading off the scale there, in fact it's a particularly nice scale as well. Reading off that, I have got 5 people here. I'm just going to write on each bar just so I can read it clearly when I go back to it. 20 there, 24 there, 34 there, 30 here, and 7 here. Now be careful with this bit. It says time in minutes, and it says less than 2.5, less than 5, less than 7.5. Now just be careful, because it's surely not going to be as simple as that. It's given me 2 marks to do it, and that wasn't 2 minutes worth of work. That was pretty easy just reading off those values. This word cumulative frequency means the running total, okay? And when drawing a graph, I'd expect it to look something like that, you know, vaguely, okay? So less than 2.5, so here was 2.5, so how many people were less than that? Well, no one was less than 2.5, so that answer is 0. How many people were less than 5? Well, 5 people. How many people were less than 7.5? So 7.5 being there, 20 and the 5 people, so it's like adding up these numbers as we go along. So 25, 49, 83, 113, and 120. You can use your calculator to this, you don't need to be doing it in your head. I know what the answer is. I've actually already done this paper, I'm just working through it now. Okay. It says the graph paper opposite shows a cumulative frequency diagram of the time taken by 140 visitors to tie a Celtic knot. On the same graph paper, draw the cumulative frequency diagram for the times taken by the local people. Okay, so I need that table to start plotting in there. So at 2.5 it was 0, so I know that goes here. And then it was 5. Now this scale's not as nice, it's not the same scale. So 20 is the jump, there's 10 little squares, so each little square is worth 2. So then at 5 and 5, so that's going to be 2.5 up. And yeah, I'm quite happy with that actually. I'm going to do the same sort of type there. 25 then, so that's going to be 20, 22, 24, 25 will be halfway up again. And then 49, so that's going to be half square down from 50. And then 83, this is fiddly to plot, they've made it hard for us. And then 113, so there's 110. 112, 114, so 113 there, and then 120 by the time we got 17.5. Now, I do this slightly different to some teachers. If your teacher's told you to do it freehand, then by all means do it freehand. However, you will not lose any marks at all for doing this with a ruler. You may lose marks freehand, so I always tell my classes to use a ruler. So I'm going to just literally join up the dots now. Okay, so that was what my graph looked like, something like that. It says the visitors have been set a target. That 100 of the group would finish within 17.5 minutes. So the visitors, that is. How many minutes did they miss or beat their target by? Okay, so we're looking for the visitors. This was the locals, the one that I drew. So I'm going to write that just so I can tell which one's which. So the visitors, 17.5 minutes, 100 of their group. So 100 of their group would be this line here. It actually fits nicely on something for once. Okay, they did it in 15 minutes. So 100 visitors did it in 15 minutes. There's no need to write that down, but if you want to, you can. Did they meet or beat the target? Well, they're supposed to get it in 17.5, so they beat it. And by how many minutes? Well, if they did it in 15, it was 17.5. They did it in 2.5 minutes. Okay. Okay, this true or false table now. It says the 10th percentile for the local people is between 5 minutes and 7 minutes. Okay, so the 10th percentile of the local people. Now, we know the locals stopped at 120, so we're looking for the 12th person here. So the 12th person, there's 10, up 1 would be 12, and I'm looking for the locals, so it's where I hit there. So that's 10% of 120. I come down here and I can quite clearly see that's 5, that's 7.5, yeah, it's somewhere between 5 and 7, yeah, that's true. Okay. The next one says 40% of the visitors took less than 12.5 minutes, sorry. So 12.5 minutes, let's go and find that. That's here, and I'm looking for the visitors. So we're coming up here and finding that answer is exactly 40, but it wasn't 100 people, it was more, wasn't it? It was 140 people. 40% of 100 would be 40, and that's less than that. So from there, I can tell you now that it's false. But if I was to prove it, I'd say, well, it's 40 out of 140 times by 100 to turn it into a percentage. That comes to 28.6. Okay, so yeah, it's actually 28.6. That was false. The estimated median time by the visitors is 13.75. So the estimated by the visitors. So the visitors, there was 140, so 70 would be the midway here. So 1, 2, 3, 4, 5 there. Draw a line across until I hit the visitors graph, which is here. Okay, now that looks doable to me, but let's just be certain rather than just guessing. So this is their median. Now, in terms of how far this is, that's a jump of 5, and I've gone 20 little squares into that. So 5 divided by 20 tells me that each little square is worth 0.25. So if I look at 15, count back 1, that would be like coming back 1 quarter, so 14.75, 14.5, 14.25, 14, 13.75. Yeah, it's true. Okay. The difference between the estimated medians of the two groups of people is about 3 minutes. So the median for the other guys, now just be careful with this because they're a different amount of people. So 120, so I need to actually come across at 60 for that. So 60, and then coming down and reading off here, comes to, so there's 10, it's about 10.75, isn't it? And that's 13.7. Yeah, so that's absolutely true. So 3 minutes. That's true. Now it says if there had only been 120 people visiting, they would have certainly all finished within 18 minutes. Now, if you look at 120 people there, come down and read off, you see it's 17.5. So you think, oh yeah, it's absolutely true, but it's not true because the one person that took really long could have still been there. Although that there were a few more people, like another 20 people that took between 17.5 and 20, they could have still been there if there had been less visitors. So someone who just took a long time. Okay, so that's false. Okay, next question. It says Lewis has a large dog that lives in a kennel. In order to design a similar kennel for a smaller dog, Lewis wants to calculate the angle of elevation. So this is an angle of elevation, one that goes up. An angle of depression would be like this angle here. If I said that angle would be an angle of depression coming down. It says it's symmetrical, so that's surely going to be important. So what it does allow me to chop that in half, make a right angle triangle. I'm quite happy now because obviously I must be using SOHCAHTOA trigonometry here. If it's symmetrical, I've chopped it exactly in half, so I assume this was 55 centimetres and this was 55 centimetres. And if that's 100 there and that's 150 there, this must be 50 centimetres. And that is the hypotenuse there. This is adjacent to the angle and this is the opposite. Now, because I know what the opposite is and because I know what the adjacent is, I'm going to write out the word SOHCAHTOA. And because it's O and A that is circled there, I'm going to cross out O and A. The one that is double crossed out is TOA. So that tells me tan X or tan theta or tan angle is equal to the opposite side divided by the adjacent side. So tan X is equal to 50 divided by 55. I will now take tan over, leaving just the angle. And when tan goes over, it changes to something a bit strange. It changes this tan to the -1, which means inverse tan, of 50 over 55. And that will go into my calculator. So tan to the -1. So I get that by pressing shift and tan. And then 50 over 55. Close your bracket. You don't really have to, but sometimes you will. Like if you're putting into the cosine rule and the sine rule, you have to, otherwise it will say math error. Or syntax error, and that answer is 42, and I always write these to one decimal place unless it states. And it actually says to an appropriate degree of accuracy, 1 dp is absolutely fine. Okay. Part B, it says explain why in practice this angle may not be as accurate as you've calculated. Now this has been done, to one decimal place. If I had a protractor, if you've got one, look at it. Look at the difference between one angle. It's absolutely tiny. So we're being very, very, very accurate here. All it takes for me is to maybe not measure accurately. So I'd say not measured accurately. Or it could have had upper and lower bounds within it. This might be 100 centimetres to the nearest centimetre or something like that. So not measured accurately. It could have been the thickness of the wood. Could have affected it. I hung a mirror the other day and it was wrong because I didn't think of the thickness of the wood. Thickness of wood. Okay, so one of those two excuses there will be absolutely fine. Okay, number 7. It says the diagonal of a flag measures 2.5 metres. Calculate the width of the flag. Okay, now I don't know how long the width is, so I'm going to call it X. Now, I'm told here that the length of the flag is twice the width. Now, don't go around calling this Y because it's linked to the width. It's twice as big, so it's 2x. Okay? Now, you should know a squared plus b squared equals h squared or c squared or whatever you want to use. I just use h to represent the hypotenuse. Now, this has to be the two sides. Now, be very careful. That's x squared plus 2x squared is equal to h squared. I actually know what this is. It's 2.5 metres, so it's 2.5 squared. X squared just means x times x. Plus 2x all squared means 2x times 2x, so that is 4x squared. Very easy to accidentally drop that mark. 2.5 squared, you should stick that into your calculator unless you know it's 6.25, but I'll just prove it to you. There you go, 6.25. Okay, now I can lump together like terms. X squared plus 4x squared would be 5x squared. Now I want to try and get the x on its own. The first thing I get rid of, you sort of work backwards through this word bid mass. So the first thing I'm going to get rid of, I've got an indice there and a multiplying. I'm going to get rid of like the bottom of that list. So I'm going to get rid of the multiply bit. So x squared equals 6.25 over 5. So x squared is equal to that answer divided by 5, which comes to 1.25. And then I'm going to take the squared over, so it'll become a square root. So x would equal, so it's a square root answer, comes to that horrible answer there, which I'll SD, and I get 1.1 meters to 1 decimal place. So the answer, 1.1 meters. Okay, if they don't ask for the length max, if they did, I'd have to double that answer. Okay. On a holiday, Theon sees her necklace priced at €168 in a shop. The shopkeeper tells her there's an error in the marked price. The rate of the value added tax included in the price has been calculated at 15%, but it should really be 20%. As Fiona has pointed, the shopkeeper offers an additional reduction of 12% after the VAT is corrected. If she accepts the shopkeeper's offer, how much will she eventually pay for the necklace? Okay, so we know it's currently had 15% added on to its original cost, and that has come to a cost of €168. Now I want to know how much it should be when it's had 20% added on. So I want to know when it's 120%. The best way to do that is to find what 1% would be. And the way that you do that is you divide by the number in front of the percentage sign. So divide that by 115, but it means, because it's an equation, it means you have to do the same thing to both sides to keep it equal. So 168 divided by 115 comes to some horrible number. Now you don't round in this question until you're completely finished. So that would be 1.460 blah 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 blah. Now that's 1%. I want to know 120%, so I'm going to times that by 120, which means I times this by 120. So I just say ans times by 120. And that comes to a little bit more, which I was expecting. If it's having 20% rather than 15%, it should be coming to more. Don't like that dot there, so I'm pressing SD to get rid of it. That's 175.30 blah 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 blah. Don't round because we're not finished. We're now getting a 12% reduction. Now the quick way to find a 12% reduction is to take away 12% from 100%. That's 88%, and if you know your decimals well, that's 0.88. Now earlier I times by 0.45 to find 45% of something. To find the 12% reduction in one go, I could times by 0.88. Alternatively, I could times this by 0.12 or find 12% of it and then take it off the answer. This is just a bit of a quicker way around it. So I'm going to do 175.30 blah 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 times by 0.88, and that will work out the answer for me. So times by 0.88 comes to £154 or €154 and 27 cent 2 decimal places. Okay, if you did actually start rounding some of these numbers, that answer didn't come out and they will penalise you for that. Question 9. It says, an engineer needs to check the density of steel produced by a factory where he works. He collects a sample of 1,000 ball bearings, each with a radius of 0.8 centimetres cubed. And now you've got to know what a ball bearing is here. It's just like a round sort of like spherical thing. So I need to go to the second page. So I needed this one as well. And the volume of a sphere is equal to 4/3 pi r cubed. So I need to find the volume of one sphere, or one ball bearing, and that would be 4/3 pi, and then the radius, I'll just change from brackets 0.8 cubed, tells me what the volume of one is. So 4/3 pi, done the wrong thing here, press 1 and just delete it, shift and pi, and then brackets 0.8 cubed. Now that comes to an answer of 2.144 blah 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 centimetres cubed for one. He has 1,000 of these, so I need to times that by 1,000. That's 100 times by 1,000, so answer times by 1,000 comes to, estimate 2144.660 blah 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 centimetres cubed. Now the big issue I've got here, it tells you the total mass is 16.935 kilograms, but it wants it in kilograms divided by meters cubed. Now be very, very careful here. Centimeters to meters is a conversion of 100, yeah? But in terms of centimetres cubed into metres cubed, that's not the same. Okay, now the formula that I've been telling my class to write down is for length, it would be the small one times by the scale factor is equal to the big one. For area, it would be the small one times by the scale factor squared is equal to the big one. And then finally, for volume, it's the small one times by the scale factor cubed is equal to the big one. That does the trick for me, but I'll try and sort of prove it to you here. If I had an area, okay, and this was, let's say it's 300 centimetres by 500 centimetres, then that would be 3 times 5, which would be 15, and 1, 2, 3, 4, 0, it's 1, 2, 3, 4. So it'd be 150 centimetres squared. Exactly the same, well, it's not a square, is it? A rectangle. Exactly the same rectangle, but this time I'll write it in metres. So it'd be 3 metres by 5 metres, which would just be 15 metres squared. Now, in terms of that, look, if I change the metres squared into centimetres squared, I've got to times by 4 zeros, 10,000, okay? So it's not true in terms of thinking, oh yeah, you just times by 100 like metres to centimetres. Not for area, and for volume it'd be even more. It'd be times them by cube, so it'd actually come to like 1.5 million centimetres cubed if we're working in terms of volume. Now, in terms of what I've got here, I've got this volume, which is 2144.6, blah, 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 and the scale factor, to change that into metres, I actually need to divide it by 100. So I'm going to write that as a fraction, say times by 1 over 100. But that's cubed because I'm talking volume, and that'll work that out in metres cubed. So answer times by fraction, and this has got to be in brackets, very important you put this in brackets, cubed, and I've got to put the brackets there, comes to an answer. Now let's put it into standard form. Minus 3 means I've got 3 zeros, so 1, 2, 3. That's my 3 zeros, including the 1 in front of the decimal point. And then 2, 1, 4, 4, blah, blah, blah. There's no point anymore, actually. That's a mistake for me. That's supposed to be an ellipse. Meters cubed. Now that answer is now in meters cubed. So now I can put it into density by kilograms, which is, so I'm going to say density would equal to 16.935 kilograms, like they wanted. Kilograms, divided by the meters cubed, so 0.002144, blah, 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 meters cubed. Okay, so I now put in 16.935 divided by ants, and I get the answer 77896, and that would be kilograms / meters cubed, and that would be to the nearest whole. Okay, you could do it to 1dp or whatever then, okay? Okay then, over the page for number 10. Says Kerry is a jewellery designer and is making a brooch. The brooch is in the shape of a sector of a circle with a radius 2.8 centimetres. Not squared, 2.8 centimetres, as shown in the diagram. Kerry is planning to cover the brooch in gold leaf. Kerry buys gold leaf in square sheets with side 80mm. Now be careful. That's in centimetres, that's in millimetres. So we could change that into centimetres straight away if we wanted to. The cost of one sheet is 48 quid. Okay, so let's work this out in terms of how much area that gold leaf will already cover. So we know it's an 8 by 8 square. So an 8 centimetre by 8 centimetres. So 8 times 8 would equal 64 centimetres squared. And that 64 centimetres squared comes to 48 quid. That's how much it costs. Okay. Now, in terms of what the area of the brooch is, the area of the brooch is, so it's the angle divided by 360, because that's what a full circle is, and then times by the area of a circle, so pi r squared, so 2.8 squared there. So 110, it's 100, 110. I made a mistake there, like 360. So 110 times by pi r squared. So 2.8 squared. So that comes to an answer as follows: 7.52 blah 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 centimeters squared. So it's a fraction of what area it will cover. Okay. Now, in terms of what I know that 64 centimeters squared is equal to 48 quid, and I want to know how much 7.52 blah 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 centimeters squared will cost. Now the way that I work that out is work out what I'm dividing that by. So if I do 64 divided by that answer, I'm dividing that by 8.5 blah blah blah. So that means I need to do this divided by 8.5 blah blah blah. So then 48 divided by that answer comes to 5.65. It's not the easiest maths in the world to do, you know, it's coming naturally to me. And I find it hard to put into words explaining what I'm doing. You know, if you're unsure where these are coming, try and pause the video and rewind it and have another look at it. It's not the easiest question in the world. I think I need these answers for the next bit. Now it says the cost of the metal that Kerry uses for the base of her brooch should be £2.28. She decides to produce a larger brooch which is a similar shape with the base the same thickness, and the radius is now 4.2. So the radius was originally 2.8 and now it's become 4.2. So I need to work out what the scale factor is, times that by a scale factor. And the way that you work that out is 4.2 divided by 2.8, and it tells you the scale factor is equal to 1.5. So in terms of the cost of this, so it says the cost of the metal that she used was 2.28. I now want to times that by the scale factor, but as I've already mentioned earlier in the video, times by the scale factor squared when I'm talking about an area. Okay, and we're talking about area because it says about the amount of metal she's used, which would be an area. Okay, so 2.28 times by 1.5 squared comes to, if I press answer, that should come back up. There we go, £5.13. So it's that one. Okay. Now, for this one here, it says, when Kerry finds that she makes the base of the brooch, she wastes 1/4 of the metal, including the waste. The actual cost of the smaller brooch should be. Okay, so the smaller brooch, now I know that 0.75, which is wasting 1/4 of it, or you could say 75%, I've used that method already in this video. 75% is equal to 2.28. I want that to be 100% to work out what the total cost is. So I'm going to divide both sides by 75 and find 1% doing so. So 2.28 divided by 75 comes to 0.0304. So then 100% I would times by 100, and it comes to 3.04, which is that answer there. Okay, pretty mean amount of marks go for that. I think that's not the easiest maths in the world. Well, you know, this is just one of those things. If you get them, great. If you don't, it's not the end of the world. It's only 2 marks. Over the page, AER, I think I said this one was coming up. So if I come back to the formula there, given I'm looking at that the whole time, you should be 2. So by all means have it ready, but I can't actually write it up. Now, in terms of what this PA or P.A means, that means per annum, that means per year. Okay, so when I'm using that formula, it's 1 plus I, which is the interest rate, but you need to write it as a decimal. So 0.076. Now, this is not an OCW question, but I'm just referencing what this is for you more than anything else. So that is the percent as decimal. It has to be as a decimal. You can't leave it as that. Divided by the number of compounding periods. Now, quarterly means it happens every quarter of the year. So how many times does a quarter go into 1? Well, 4 times because it's a quarter. And then that number there is always the same there as the power. Now, this will come out as a decimal, sorry, -1. This will come out as a decimal, and it always comes out as a decimal, and you need to times it by 100 to change it back into a percentage. So I'm just trying to write that into my calculator the way it looks there. If I can't make it look exactly the same, then it's you know, I'm going to do it wrong. So that's 0.07819 blah blah blah, times that by 100 to get 7 points. Now in terms of DPs, I normally go to 1, but it quite clearly says in the question to go to 2. So it's 7.82% to 2 decimal places. 7.82. In terms of why banks use AER, it is to fairly compare different bank accounts. Okay, fairly compare different bank accounts is what you need to know for that. Okay. You should have seen stuff like that in class. I know my class has seen that, so I'm hoping you've seen it as well. Okay, number 12. Now I've seen the question since this before. I think it's a particularly nasty question. So it's saying it's like a dog toy or something like that, or part of a child's toy. It's like the circular thing here. So you have a cylinder and they've bent it round like that. Okay, this is obviously the centre here. It says, can you work out an approximate value for the volume of the ring? So how would I work out the volume of the ring? Well, I need to have it as a cylinder, and then to work out as a cylinder, just try and draw it very, very roughly there. I need to know the area of this thing here. I need to times it by how long the length is. Okay, so the volume equals pi r squared. They sometimes call that h, pi r squared h. Maybe rewrite it as that. Now, in terms of when I cut that thing there and bend it out, I'm going to have two different lengths here. Now, I'll straighten that out, and I've got the inner ring here, which is actually smaller than the outer ring. It's been stretched to go around here. So I've got two different things. And when I do cut that open and stretch it out, I'm working out the circumference. So the formula for circumference is 2 pi r, or you could use pi d. Okay. So for the small or the inside ring, inner, it would be 2 pi times by 9, which is 2 pi brackets 9, which is 18 pi, which is 56.5 blah blah blah. For the outer, it would be 2 pi times by 10, which would be 2 pi times by 10, which would come to 62.83 blah blah blah. Now there's two ways to think about this now. You can either say, well, there's quite a few ways. You can say, well, it has to be that one because it's the smallest one there, that's what it was originally, but you could argue it could be that as well after being stretched. You could argue it wouldn't actually make a cylinder again. I think the fairest way to work out what that height is to actually take an average of that, and it said something here, it says, state and justify what assumptions you've made in your calculations and the impact they've had on your results. So, I'm going to take the average because I think that's the fairest way to do it, okay? So, I'm going to do 2 pi brackets 9 plus 2 pi brackets 10, and I'm going to divide that by 2. So, 2 pi brackets 9 plus 2 pi brackets 10 divided by 2 comes to an answer of 59.69 blah blah blah. Okay, now I need to state here, this is my assumption, okay? I have taken the average of the inner slash outer, which I'll try and spell correctly this time, I was aware that should have just been the 1t, inner slash outer circumferences. But that's just stating what assumption I've got to make. Why have I done that? I need to say why I've done that. So the reason why is because the length is between 9 centimetres and 10 centimetres. Okay, so something along those sort of lines. So now to work out the volume of that, it would be V equals pi r squared times by the h. Now in terms of what this radius is, we know that the diameter is 1 centimetre, so the radius must be 0.5. So it would be pi 0.5 squared and then times by that long answer I've got here, so 59.69 blah 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 answer. Okay, so shift pi brackets, shift pi 0.5 squared and then times that by the answer will give me 46.88 centimetres cubed to 2 decimal places. There. Okay, Dewey was a cyclist, sounds like a bit of a legend already. He travelled along a straight flat road to the bottom of a hill and cycled up. The gradient of the hill was consistent at first, then it decreased near the top where Dewey stopped for a rest. Dewey maintained the same rate of effort throughout his journey. Which velocity time graph represents his journey? Okay, so try and get all 5 there on the screen. Now think about it, you're going along a straight flat road. You then see a hill, what's going to happen? You're going to slow down, aren't you? And as you go up that hill, because you're maintaining the same effort and it's a standard gradient, you're not going to lose any speed. You're not going to lose any speed, but you're certainly going to start going at a constant speed. So, you know, when I go up a hill, I go up around about, I don't know, say 7 miles an hour. When I'm going along a straight, flat road, going about 20 miles an hour. So I'm expecting to see that I'm going quite fast. Then I've hit the hill, so my speed dramatically drops, but then it steadies off again. And it says that the gradient decreased near the top. So if it's getting flatter and flatter and flatter near the top, that means I'm going faster and faster and faster. So which graph is doing that? That would have to be D. Okay, why? I'm going fast along my straight horizontal road. I then hit the hill, so my speed drops. I then maintain going at that speed because it's a standard gradient, and then it starts flattening off. So that means I can start going quicker and quicker and quicker. But why other than that? I'll stop for a rest. So I've got to stop, okay? If you chose like this one here, or this one here as well would be a good example, maybe even those ones there, or A, B, or C, they're good examples of what the hill probably looked like rather than what the speed did, okay? The graph that represents this journey is D. Okay. Last bit of the paper now, so we're coming up to this bit here, and then we're on to the final page. It says, later in the day, Dewi's greatest velocity was 22 meters per second, measured to the nearest meter per second. In the location, the speed limit was 80 kilometers per hour. Is it possible that Dewi exceeded the speed limit? Okay, so it measures the nearest meter per second, blah, blah, blah. Okay, so we need to work out his upper bound and his lower bound of what his speed could have been. Now, if he was doing 22 meters per second to the nearest meter per second, that means the nearest 1 meter per second, which we divide by 2, which comes out of being 0.5 meters per second. To find the upper bound, we'd add that on. That would be 22.5 meters per second, lower bound 21.5 meters per second. Now, in terms of what I'm trying to look at here, I'm trying to look at me exceeding the speed limit. It says it's possible he's exceeding that, so I'm going to work primarily with the upper bound. So 22.5 meters per second times that by 60 comes to 22.5 times by 60 comes to 1,350. But what is that? Well, that's meters in 1 minute. Okay, meters in 1 minute. I then need to work out that into hours because it says 80 kilometers per hour. So how many minutes in an hour? 60. So that is 81,000 meters in 1 hour. And I can tell from there that's 81 kilometers because I know that it's 1,000 that goes into a kilometer. So it is possible that I'm going at 81 kilometers there. So I'm going to say yes if he travels at upper bound or close to it, like, you know, maybe 22.4 would have done it as well, but I proved that he's done it anyway, so I'm not going to go any further than that. Okay, final question, and then I'm going to show you this thing here. Now, I've circled this thing here. Now, I'm not really using that because that's not a cone, but it doesn't look drastically different to it, does it? In terms of what this formula says, it says 1/3 pi r squared. Now, that is the base area. Okay, so I've showed my class how to manipulate this formula times by the height to work out the volume of a cone. So if I want to use it for this, I'm going to say volume pyramid, which I can never spell, so I'm going to look there, pyramid is equal to 1/3 times base area, and then times that by the height. Okay, now I've got some similar shapes going on here. I can see there, that's 60. And I can see there, and that's 45. Now I just spotted a link straight away. I know that if I do the big one divided by the small one, 60 divided by 45, that'll work out the scale factor for me, which is 1.3 recurring, which I'm actually going to leave as a fraction because I think it's a bit easier, is equal to scale factor. Now that means I can work out exactly how big that thing is there. Okay, now I've got the height of the big one there, so if I want to find the height of the small one, I just need to divide it by that number. So 120 divided by that answer tells you that this must have been 90 centimetres, and that was all through similar shapes. Okay, so your similar shapes knowledge had to be quite strong in this paper. So to work out the volume of that frustum, volume of frustum would equal would equal the big pyramid, so I'll just call it the big P, take away the small p. So that is going to be a third of the base area, so that's a third of 60 times 60, and then times that by a height of 120. I then need to take away, very similar calculation here, so a third times by 45 times by 45, and then times that by 90. So that's going to work out the volume of that frustum frame. So there we go, press equals, and hopefully I get the same answer I did when I did this before, which was 83250. Now that would be centimetres cubed, okay? But just check you've done what it says here. It says calculate the volume of the concrete required to make the base of the garden statue. Give your answer in litres. You need to know the conversion from 1 litres to centimetres cubed is 1,000. So if I divide that by 1,000 there, I'll get that answer in litres. So divide that by 1,000 comes to 83.25 litres, and that concludes the last PPE.